Hello, everyone. My name is Avani, and I'm the Cloud FinOps Product Manager at OpenMetal. I was first introduced to OpenStack here at OpenMetal, and as a content creator, I had to quickly understand OpenStack and who can benefit from using this amazing software. It was initially an uphill climb, and there's always new things to learn, but I'm finally at the point where I can have some fun with it. My passion ignited when I was able to combine a curiosity of mine, AI, with OpenStack. User-friendly AI that everyone could use, such as Gemini and ChatGPT, has AI on the tip of everyone's tongue. Even my 8-year-old was recently arguing with me that we no longer needed Google because AI programs like Gemini provided better answers to his questions. I didn't have the heart to tell him that while he was complaining about having to read through websites to find his answers, when I was growing up, we asked the librarian and then had to read books or research papers. But AI is transforming the world. 3 years ago, I couldn't fathom Google being replaced as our go to source for finding information. And now, even I ask AI 90% of the time when I have questions. This wave of transformation opens worlds of possibilities. And if you're looking for ways to leverage AI for the success of your organization, then this presentation is for you. It may be intimidating to consider embarking on an AI project, thinking about investing in costly enterprise package infrastructure for your AI as well as building your program. However, the truth is AI is flourishing because the tech landscape, including the open source sector, has evolved in a manner that easily accommodates the needs of AI. In this presentation, we will explore OpenStack projects and additional open source tools that you can integrate within your OpenStack deployment to ensure resilient infrastructure for your AI project. Let's begin by considering the resources that your AI workloads may need. You will need CPU for general purpose computing tasks, GPUs for accelerating deep learning workloads, TPUs for accelerating machine learning workloads, and field programmable gate arrays can also be used for accelerating certain AI workloads through hardware acceleration. You will need sufficient RAM to store model parameters, intermediate computations, and data during training and inference. AI workloads often require large amounts of data for training modules, therefore, high capacity and high speed storage solutions are necessary to store dataset, model checkpoints, and other related data. High speed networking infrastructure is crucial for distributed training scenarios where multiple GPUs or TPUs across different servers need to communicate efficiently. You will need AI frameworks that can be used for developing and deploying AI models, and libraries for distributed computing may be required for scaling training across multiple nodes. OpenStack is designed to be highly scalable and open source, and the open source nature of the code provides users with the control needed to customize the infrastructure as they need. Some key OpenStack projects that can help support AI workloads are Nova, Neutron, Cinder, Swift, and Heat. These are core projects that are usually included in all OpenStack deployments. Nova manages both the compute resources and the memory allocation for instances, making sure your AI workloads have sufficient RAM available. Neutron is OpenStack's networking service, which enables the creation of isolated networks, load balancers, and security groups, ensuring that AI and machine learning workloads operate securely and efficiently. Developers can design network architectures that isolate AI and machine learning tasks, preventing interference from other applications and enhancing performance. Swift is OpenStack's object storage service. It provides a scalable and redundant object storage. Swift is designed to scale from a single machine to thousands of servers and is optimized for multi tenancy and high concurrency. AI workloads require large data sets and model checkpoints, which can be stored on Cinder volumes, which are attached to VMs. Cinder is OpenStack's block storage service. AI and machine learning models thrive on data. OpenStack storage services, including Swift for block storage, for object storage, and Cinder for block storage, provide scalable and reliable options for storing large data sets. This enables seamless access to the necessary training and validation data, a fundamental aspect of building accurate and effective models. Heat is OpenStack's orchestration tool and can be used to automate the deployment and scaling of AI workloads on OpenStack. But your options do not stop there. The beauty of OpenStack is that it's designed to allow for integration with other open source software, and this includes TensorFlow, PyTorch, Jupyter, and Apache Spark. TensorFlow is an open source software library developed by Google for building and training machine learning models. It is designed to allow developers to create and train neural networks for a variety of tasks, including image and speech recognition, natural language processing, and recommendation systems. TensorFlow uses data flow graph to represent the computations that occur during the training of a neural network. This graph consists of a set of nodes that represent mathematical operations and a set of edges that represent the data that flows between these operations. PyTorch is another open source machine learning library that's becoming increasingly popular in AI applications. PyTorch is designed to be more user friendly than TensorFlow. It is designed to be efficient and scalable, and it supports both GPU and CPU acceleration, which enables it to handle large data sets and complex neural network architectures. Jupyter is an open source web application that allows you to create and share documents that contain live code, equations, visualizations, and narrative text. Jupyter is commonly used for data exploration and manipulation, prototyping and developing machine learning models, and sharing results and analysis with collaborators. It also supports a wide range of programming languages, making it a versatile tool for a range of data science and AI tasks. Apache Spark is an open source distributed computing system. It can scale horizontally across large clusters of machines, which enables it to handle massive data sets and perform complex computations quickly and efficiently. Not only can Spark be easily integrated with OpenStack, it's interoperable with other popular AI tools and frameworks such as TensorFlow and PyTorch. Now, we couldn't talk about tools for AI without discussing Kubernetes. Isolating workloads in containers is still a preferred practice. Some like to use instances as containers, but others prefer to use K8s. In the 2022 OpenStack user survey, we saw that Kubernetes is deployed on 85% of OpenStack deployments. It's such a common practice that OpenStack providers enable it by default. I know in all clouds there are turnkey Kubernetes, so it's just as easy to spin up a K8s cluster as it is to deploy an instance. Containers managed by Kubernetes provide a robust platform for deploying, scaling, and managing AI workloads, offering benefits such as isolation, scalability, resource efficiency, high availability, and automation. Containers can be used to encapsulate AI models, libraries, and dependencies, which ensure that they run consistently across different environments. This isolation ensures that AI workloads behave predictably regardless of the underlying infrastructure. Kubernetes enables auto-scaling of containerized AI workloads based on demand, which is useful for AI applications because they tend to have fluctuating resource requirements. This allows them to dynamically scale up or down to handle varying workloads efficiently. Kubernetes allows for efficiently scheduling and orchestrating containers across clusters. This ensures that AI workloads utilize available resources effectively, maximizing performance and minimizing costs. Kubernetes provides mechanisms for ensuring high availability and fault tolerance of AI workloads by automatically restarting failed containers, rescheduling them to healthy nodes, and distributing workloads across multiple nodes to minimize downtime and disruptions. Kubernetes offers built in mechanisms for service discovery and load balancing, facilitating communication between different components of AI applications. This enables seamless integration of AI models with other microservices and data sources. Kubernetes supports multi cloud and hybrid cloud deployments, so it gives you flexibility. And because AI requires a massive amount of data, self storage cannot be brushed over. Self scalability, reliability, flexibility, performance, cost effectiveness, and integration capabilities make it an excellent choice for AI storage requirements. Ceph is designed to scale horizontally, meaning it can efficiently handle large amounts of data across numerous nodes. As your AI projects grow, Ceph can seamlessly expand to accommodate the increasing storage demands without significant performance degradation. Ceph utilizes a distributed architecture where data is replicated across multiple nodes. In AI environments where data integrity is critical for training and inference tasks, Ceph's reliability is highly advantageous. Ceph supports various storage interfaces, including object, block, and file storage. Ceph employs a distributed storage architecture that can leverage the aggregate performance of multiple nodes, providing efficient data transfer rates and low latency access of data. But the best part for AI workloads is that many AI frameworks and platforms such as TensorFlow, PyTorch, and Apache Spark can seamlessly integrate with Ceph storage. This integration simplifies data management tasks and it enables efficient access to training data and model checkpoints, facilitating streamlined AI development workflows. Now, the concept of combining these various open source tools to create a infrastructure for AI extends beyond theory. It's actually being done, and we're going to look at a few examples of organizations using OpenStack to host their AI workloads. NVIDIA uses OpenStack Swift Storage as part of their cutting edge AI and machine learning data management. Machine learning demands massive data sets that are too much or too large to fit into GPU memory or server flash storage. One solution for this problem is object storage, which offers high throughput and large capacity, although with differing APIs. So, you having an open source project like Swift allows you to customize your object storage to support your program's data access pattern. This one should not be a surprise for anyone. Red Hat is using OpenStack. And I recently came across a presentation on YouTube on AI Thunderdome where they use OpenStack to accelerate the AI training. Their focus was on leveraging OpenStack's capability to support parallel AI training. They use objects projects like Spark and Sahara within OpenStack to prepare, deploy, and optimize AI models for efficient training. The use of Spark allowed scalable data processing, while Sahara streamlined data access and cluster management. And Pipestream, an self-service automation platform that transforms how businesses engage with their customers, runs their AI chat platform on OpenStack. Pipestream moved workloads from AWS to OpenStack because they wanted the ability to optimize their cloud. They are fans of open source and wanted to use OpenStack but didn't want the complexity of setting up and maintaining their own OpenStack. And because OpenMetal deploys their OpenStack for them, I can tell you a bit about the infrastructure setup of their workloads. Um, Pipestream had OpenMetal build and deploy a cloud for their DevOps infrastructure, and this included a private cloud core with three standard servers running their control plane. The addition of several large V1 servers added in a converged fashion, no control plane, compute, and storage only, a Ceph network distributed storage cluster, and OpenStack API integrations and cloud capacity to run Kubernetes across 140 compute instances. Pipestream leverages the capabilities of Kubernetes, Ceph, and OpenStack to support their AI project. Looking at the various examples of AI on OpenStack, some of the key reasons organizations choose OpenStack were scalability, flexibility, cost effectiveness, and storage options. The ability to optimize every aspect of your cloud, from the compute to the networking and storage, gives your AI program the edge it needs to process massive amounts of data quickly. If you're looking to take on an AI project, I hope you tap into the many available open source resources for your project. And if you have workloads that you want to test on OpenStack, you can provision a complimentary three-server cloud from OpenMetal so you can test a production-ready OpenStack infrastructure. And of course, if you want to continue the discussion or have any questions, please do not hesitate to connect with me on LinkedIn or via email. Thank you.